Good evening, everyone. Just wait for 1 or 2 minutes so that remaining people will also join. Hope you are all doing good at your places. Request everyone to stay at home. Right? Be careful while you are going out. Don't forget to wear the mask. It seems the second wave of COVID is coming. Request everyone to take care of yourself. This is very much important, sir. If you are healthy, then only you can do anything. So health is very important for all of us. I'm just waiting for a few more people to join. So you can wish me in live chat box. Good evening, so that I can understand who are all online. Shriyata, good evening. Harish, good evening. Venugopal, good evening. Pujita, good evening. Tejaswini, good evening. Okay, slowly the count is increasing. Sricharan, good evening. Hope you are all doing good. Vikas, good evening. Sandhya, good evening. Okay, let's start. Let's start session. Okay. See, we are discussing about a subject for GATE examination called electronic devices, and this is the lecture number 3. That is the second part of semiconductors physics, right? Which is the major topic for electronic devices. Which is the major part of electronic devices. So, for those who joined for the first time, just I have to introduce myself. Myself, H. Shravan Kumar. I am having 10 plus years of teaching experience, and I have master's degree. I have master's degree from JNTU H Hyderabad in VLSI system design. So I have mentored many people for GATE and ESE. Now my areas of interest are EDC, which I am dealing right now. This is an important subject. As I told you, around 10 to 11 marks we are going to get. 10 to 11 marks we are going to get in the GATE examination, and I'm also comfortable with analog electronics. Generally, the analog electronics nothing but some part of your ECA, some part of PDC, pulse and digital circuits. ECA means electronic circuit analysis. PDC, pulse and digital circuits, and you will have LICA, linear IC applications, linear integrated circuit applications or analysis. Is what analog electronics means. What is digital electronics, sir? Digital electronics is nothing but generally your STLD, microprocessors, and computer organization. These three subjects comes under digital part of your gate. Okay, EMFT is nothing but electromagnetic waves. This is also one of the important subject. Good evening, Shalini. Okay, now we will move on. So as I told every day, this is also again I am repeating. Those who did not install this app, Unacademy app, I request you to download this app from tomorrow. Tomorrow evening we will not have any YouTube session. We will have a session on Unacademy app. Those classes also free classes. We call them as free classes, special classes. I will share the link after this class. So or you can just go and search on Unacademy app, and you can install this Unacademy app by clicking on it. You are all masters in installing different apps. You always play with apps. You are very good at apps, right? So okay. Now the third important thing is you have to select the goal. As I told you, Unacademy is offering many students in many different ways. Somebody who is interested, Ravi Royal, good evening. CGPSC, MPSC, TNPSC, CSIR, UGC NET. This is also very important, sir. This is for the graduates who are already finished their graduation, the NET, UGC NET, which will be conducted by University Grants Commission, which is also very much important. And NTA, UGC NET, the CSIR is for non-technical, and this NTA is a technical. Non-technical and CSIR is different. And then you have GATE, ESE and IIT JAM. IIT JAM is for those students who are intermediate, and you can ask your brothers and sisters to do also this. And for our discussion, important thing is this. This is GATE, ESE is your goal. GATE, ESE is your goal. After installing, you should select this GATE, ESE. Then step 4 is you should go for plus subscription. Select a plus subscription. So then when you click on this, select this plus, so you'll get it here, get subscription. Get subscription. Vikas, good evening. हिंदी में भी नहीं है क्या? I can manage हिंदी, right? But still try to थोड़ा मेहनत करो हिंदी में सुनने के लिए, इंग्लिश में सुनने के लिए. बीच-बीच में मैं हिंदी में भी बता सकता हूँ. Okay, my Hindi is not fluent Hindi, so please bear with me. Okay, right. Step 6 is nothing but selection of your number of months. This is 12 months and 24 months, whichever is. The important thing is here. The important thing is here. What is that, sir? This promo code. This promo code. What this promo code, sir? SVS promo code is a promo code for me. That when you use this promo code, what will happen is you will get 10% discount on the fee structure. Whatever may be the fees, whatever may be the fees, whatever your fees, whatever your fees. Okay, so you will get 10% concession on the fee. So you can pay through debit card, EMI, UPI, wallets, net banking, whatever, whichever you want, you can pay. And the amount is going to be 22,500 for 12 months, 27,000 for 24 months. You just see sometimes this will be varying depending on the month. Depending on the month, this amount will be varying. But this is sure. If you use the SVS 10, you will get 10% discount, sir. You will just get 10% discount. I request those students who are targeting for 2022 to start either for this 24 or 12 months preparation. You have a lot of time right now because you are, I think, attending online classes. So you take some time every day, 2 hours or 3 hours to to study for GATE examination. As I told you, GATE is very important for those who wants a good life, right? So someday I'll try to explain you why GATE is so important for the student who are in who passed out engineering, right? Okay, let's move on. So today's topics are atomic energy levels. First topic is going to be atomic energy levels, and second topic is going to be electronic structure of elements. Okay, this is very important topic also. Of course, all the four topics are very much important. The energy band theory of crystals is also important. And the last one is like insulators, semiconductors, and metals. So each of them are interlinked. The atomic energy levels, if you study atomic energy levels, you'll understand this electronic structure of elements. After that, you'll see how the energy band is formed in a crystals. How energy band is, what you mean by band, and how this band is formed. You will study this later. Based on this energy band, we will talk about how materials are classified into insulators, semiconductors, and metals. Okay, so these are all interlinked. Today's class is very much important, sir, because it plays major role in understanding the next topics of semiconductors. Clear? So before going to the topic directly, we will try to see what we discussed in the previous class. Just summarize for this. We'll spend 2 or 3 minutes. We'll spend 2 or 3 minutes. So in the last class, in semiconductor physics first class, so this is all. Yeah, what we have discussed is Rutherford atomic model we have discussed, and what is the weakness of Rutherford atomic model we have discussed, and then Bohr atomic model. Quickly we will go through, sir. So we have also discussed about what is a field intensity. What is field intensity, sir? Force on a unit positive charge is called field intensity. This is what I explained you in the last class. So units are going to be volts per meter, field intensity, and then we have discussed potential. What is potential, sir? The work done against a field in carrying a unit positive charge from one x0 to x. That is, so we have seen here. So the work done to move a positive charge from this place x0 to x, which is against to the field. This is, we have to remember, sir. So the formula is going to be v is equal to a minus of integral e dx from limits are from x0 to x. So why this minus, sir? Because we are working against to the field. So field is in this direction and we are working in this direction. Clear? And if both of them are in the same direction, there is no work done at all. Okay. So this is what we discussed, and then we talk about potential energy. Simply, potential energy is a multiplication of the charge and its potential. Charge which is placed in a electric field multiplied by its potential is nothing but potential energy, and units are joules. Units are joules. And the electron volt unit of energy. The electron volt of energy is the unit of energy. As I told you, this joules is a very big unit. As we have kilograms, grams, and milligrams to measure the weight of some system. So weight. Similarly, to measure the energy, we have another unit called electron volts, like ergs and electron volts. We have discussed in detail why we have got this. Because this is useful for electrical students also. This is useful for electrical students also. And we have seen what is the value of 1 electron volt. 1 electron volt is going to be 1.602 10 to the power minus 19 joules. Okay. And then we started with something matter. What is matter? Any substance which contains some weight and space is called matter. Matter is divided into molecules without changing any identity. And each molecule again subdivided into atoms. And atom contains 3 principal parts called electron, proton, and neutron. Electron, proton, and neutron. So what Rutherford says is all the positive charge is located at the center of the atom, which contains both protons and neutrons, and it is called as a nucleus. right? And the electrons will be revolving around the nucleus in circular orbits, circular motion, and we call it as orbits. We call it as orbits, right? And it will be moving with very high speed. And simply, it is like how the planets are moving around the sun. This is what Rutherford told. So we have discussed about what is this atomic number, what is atomic mass number, and what is the mass of an electron, everything. So just to those who have attending first time, for the sake of them, for the first time, this is just I am rewinding. Okay. So charge of an electron, mass of an electron we discussed, and then now then we started discussing about this. The force of attraction between these electron, the positive charge and negative charge is going to be F is equal to minus E square by 4 pi epsilon naught R square, where E is the charge of an electron, epsilon is the permittivity of the free space, whose value is going to be 8.854 into 10 to the power of minus 12 farads per meter, and R is the radius of an atom. R is the radius of an atom. Okay. So and we have discussed why it is centripetal force and everything. And we have derived some equation mv square is equal to ae square by 4 pi epsilon naught r, and we have concluded that the energy of an electron is negative. So this, as I told you, this is very important formula, that is Wn, W is going to be minus energy of an electron, energy of electron is going to be minus e square by 8 pi epsilon naught r. And then what is the weakness of this Rutherford atomic model is, so whenever, according to the classical electromagnetic theory, whenever an opposite charge is revolving around the positive charge, let's say this is positive, negative charge is revolving around, what happens is slowly it loses its energy and it will try to fall, into the nucleus, but which is not possible, in general, okay. So this is what Rutherford failed to explain. If the electron is trying to revolve around the nucleus, and when it starts losing the energy, radiates energy, what happens are, when it is losing energy, it should come towards the nucleus, and at some point of time, it will fall into the nucleus. That is what Rutherford was unable to describe. And here comes the Bohr's atomic model. What Bohr says is, atom possesses certain discrete energy levels, not continuous energy levels, discrete energy levels, and when the electron is revolving around this discrete energy levels, it will not radiate any energy, and those orbits are called stationary orbits or non-radiating states. And but when electron is moving from one state to other state, it loses some energy, and how we are going to express this, you can see here from W2 to W1. W2 to W1, it is moving. So when it is moving from higher states to lower states, what happens, sir? Some energy will be lost. And the radiating energy, the frequency of radiating energy is directly proportional to the energy difference between these two, and which is equal to, F is equal to W2 minus W1 by H, which H is Planck's constant, which is equal to 6.626 in 10 to the power minus 34 joule second. And we have derived the this, and this lambda is a wavelength. If it is expressed in micrometers, it is going to be 1.24 by E2 minus E1. If it is expressed in angstroms, it is going to be 12,400. Why it is 12,400? Because 1 angstrom is going to be 10 to the power of minus 4 micrometers. In some cases, in the examination, you should be very much careful whether the answer is asked in angstroms or micrometers. And we have also solved this problem, which is recently, I mean 2014 is not too late, but you can get easy questions like this also. No? We have discussed and this problem. Here comes the third important statement of Bohr. The stationary state is determined by the condition that the angular momentum of the electron in this state is quantized and must be integral multiple of h by 2 pi. So the angular momentum is talking about, and it is equal to the integral multiple of h by 2 pi. And we have derived, sir, what we derived is, for Wn is equal to minus me square by 8 epsilon naught square h square into 1 by n square. For an hydrogen, what you will do, sir, you substitute the value of m, E, mass of an electron, E is the charge of electron, this is a permittivity of this free space, and h is the Planck's constant. If you substitute this, what you will get, sir? W is equal to minus 13.6 by n square. Electron volts is a unit. Electron volts is a unit. Okay, if you want to convert it into joules, what you will do, sir? Just multiply it by 1.602 10 to the power minus 19 joules. Okay, the electron energy of electron is inversely proportional to 1 by n square. This is where n is the orbit number. So as the n value increases, the energy of electron increases. What it means, sir? When electron is trying to go away from the nucleus, its energy is increasing. Or when electron gets some energy, it will try to move away from the nucleus. That is what the statement is. So this is what we have discussed in the yesterday's class. Now let us move on to the today's topic. Okay. Now from previous discussion, what we have done, sir? From previous discussion, so the energy of electron is going to be minus m into e power 4 by 8h square epsilon naught square n square. Here m is constant, e is constant, h is constant, epsilon is also constant. All these constants we have applied. So what we got exactly is, for an hydrogen atom, since Wn is going to be, yesterday also we have discussed, it is nothing but minus 13.6 by n square. 13.6 by n square, where n is the orbit number. N is orbit number, either it orbit 1, orbit 2, orbit 3, right? As electron may be moving in different orbits. Now let's consider for, let's say, for different values of n. So let n is equal to 1. For n is equal to 1, what we will see? For n is equal to 1, what is Wn, sir? Or we call it as W1. The energy value is going to be what, sir? Minus 13.6 electron volts. So for n is equal to 2, so if you substitute n is equal to 2, that is W2, what you will get, sir? Simply 2 by 4 minus 13.6 by 4 minus 13.6 by 4, what you will get, sir? Almost you will get minus 3.41 electron volts. Minus 3.41 electron volts. Right? Now, when n is equal to 3, what is W3? That is minus 13.6 by 3 square 9. 3 square 9. What you will get, sir? Minus 1.53. Minus 1.53 electron volts. If n is equal to 4, what you will get, sir? W4, that is what? Minus 13.6 by 16. Numerator is lower than the denominator. So what you will get, sir? You will get less than. So you will get 0.87 electron volts. Similarly, for n is equal to 5, what is W5? The energy, again, minus 13.6 by 25. So you will get almost minus 0.56 electron volts. So see, as the value of n is increasing, the energy of the electron, is increasing or decreasing, sir? Increasing or decreasing? It is increasing. Why, sir? This negative sign you can see here. Minus 13.6 is less than minus 3.4. Yes or no? Yes or no? So now I just wanted to know. So for what value of n? For what value of n, W becomes 0? For what value of n, W becomes 0? Can somebody answer the question? For what value of n, the W becomes 0, the energy becomes 0. From -2, it is increasing negatively, sir. So, what happens, sir? You are slowly, the energy is increasing. What? When W is equal to 0, to make W is equal to 0, what should be the value of n? What should be the value of n? Okay, I will answer, I will tell. So to see, as n is in the denominator, as the n is in the denominator, if W has to become 0, n has to be infinite. N has to be infinite. Okay, n has to be infinite. So for n is equal to infinity, the W becomes 0. The W becomes 0. So now for different values of n, you have different energy levels. For different values of n, you will have different energy levels. Now let's see. Now what we'll do is we'll try to draw energy level diagram. So we'll try to draw the energy level diagram. We'll try to draw the energy level diagram for different values of n. For different values of n. So let us say, okay. For different values of n, I am trying to draw, sir. Approximately, I am trying to draw. N is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. So at some place n is equal to infinity. So what I'm trying to write here is, for this is going to be, let's say, 1, this is 2, this is 3, this is 4, this is 5, this is 5, this is infinity. What is this, sir? This is the value of n. For different values of n, we got different values, right? So what are they, sir? For n is equal to 1, what we got is, this is minus 13.6. This is minus, in the previous, minus 3.41. This is going to be minus 1.53. This is going to be minus 1.53. This is going to be minus 0.87, and this is going to be minus 0.56. And for n is equal to infinity, you have 0. What is this, sir? This is going to be energy, E or W, in electron volts. In electron volts, right? In electron volts. So for n is equal to 1, we call this as a normal state. We call this as a normal state. Normal state, right? Normal state. But all remaining are called excited states. Remaining are called excited states. Remaining are called excited state. Remaining are called excited states. This also called as ground state. You can also call ground state. You can also call ground state. Or you can call this as excited states or radiating states. This is non-radiating states or radiating states. Now what happens is, if the electron is given some energy, now what happens is, electron will gain some energy and move into the next levels, which is far away from the nucleus. So wait, I'll try to also explain you. Just wait. The shapes, because it parallelly I'll try to draw them also, so that you'll understand. So that you'll also understand. Wait a second. See what I'm trying to do. Okay. Now see what I'm trying to do is, assume this is going to be nucleus. This is going to be the nucleus. Now one electron is here. What is that? That is ground state or normal state. Now when you supply some energy to it, when you are supplying some energy to it, now what happens, sir? This will move from this state to the next state, or it may move to this state. Okay, when some energy is given to the electron, it may jump to the next state. Which is away from the nucleus. Mahendra, it is called radiating state. See, these are called non-radiating states. Excited states are non-radiating states. Right? The previous also we have discussed. Okay. Now see, now what happens is, let us say you are giving what 1 minute. I have to tell this, right? So if you supply some energy, it may jump from here to here. Electron may jump from here to here, or it may jump from one state to the next state. When you supply some energy, the electron which is here, may jump from one state to the first state to the second state. There is a possibility that if the electron energy which we are giving, extra energy which is giving, it may go away from the nucleus, far away from the nucleus. It means there is no force of attraction between this nucleus and the electron when it is getting some energy, some external energy. And this is called detached. So, if it gets some energy, it will move from state 1 to some state, one state to second state or third state or fourth state or fifth state. But if it gets an amount of energy which is sufficient to go completely away from the nucleus, so it has to detach. From the nucleus. Then that potential is called ionization potential. That potential is called ionization potential. So the energy required, what is definition for ionization potential? The energy required for the electron to completely detach from the atom is called ionization potential. Is called ionization potential. So if you look at here, so what might be the energy required for the electron to go to zero? Means ionization means almost you need 13.6, 30 plus 13.6. You need plus 13.6 electron volts energy is required for the electron to detach. Electron detachment, which is nowhere related to the nucleus. So the external energy which is required for the electron to move completely away from the nucleus, to detach from the nucleus, to detach from the atom is called ionization potential. In this case, for a hydrogen, what is that amount, sir? It is going to be 13.6. It is going to be 13.6 electron volts. 13.6 electron volts. Clear? This is very much clear. Now, before talking about this, so how can you make this, sir? How can you make this? Let's say some electron is here, some electron is present here, some electron is present here. How can this move from this level to this level, sir? This level to this level? Some external, you are trying to supply some external energy, some external energies, and it is called collision. If an electron collides with an atom in the electric field, if you are supplying some electric field, because of which the electron may go out or move away from one level to the other level. One level to the other level. Let us say you are try to supply this amount of energy, 13.6 electron volts you are trying to supply. Now what happens, sir? The electron completely detaches. It will not just move from this state to this state, this state to this state, this state to this state. It will move away from here. It becomes free. Move away from the become free. So what happens, sir? Already one electron is there. You got one other electron and another ion is formed. So if the supplied energy is more than the ionization potential, what happens, sir? You will get what you will get? You will get one electron free, which is already electron free, the bombarded electron. Apart from the bombarded electron, you will get another electron, and apart from that, you will get an ion. So three things will form. So just try to let me recap. If the energy is not sufficient, if the external energy is sufficient, it will move from one state to other state, from 1 to 2 to 1 to 3, 1 to 4, 1 to 5, whatever. But if the energy is sufficient to detach, it is called ionization potential. If the energy is more than ionization potential, what happens, sir? You will get three things. One already bombarded electron, and one already free electron, and the third one is an ion also forms. So three things will form. Now what happens, sir? The electron which is excited from this level to this level, will not stay here for long time. What it will do, sir? After some point, it has to come. It has to come back to its original level. So the electron which is already there, it has to come back to its original level, whatever, whether it may be moving from one state to the second state or one state to the third state, whatever, whichever electron. So it is moving from one state to second state or one state to third state. It has to definitely come back to its normal state after some point of time. So that is called lifetime. The lifetime of electron is going to be, let's say, very simple. I think it is going to be, sorry, it's going to be, I think, 10 to the power of minus 7 seconds to 10 to the power of minus 8 seconds. So which is almost equal to nanoseconds. So the electron which is excited, the electrons which are excited will not stay in the same position. It has to definitely come back. Whenever it is coming back, whenever it is the electron is coming back from, let's say it is coming back from, let's say, this fourth state, from fourth state to first state. I'm assuming, sir. I'm assuming. So earlier it was gone from state 1 to state 4. Whenever it is coming back from the fourth state to the first state, it has to release some energy. Yes or no? Because it has gone from lower energy level to the upper energy level. It is from lower energy level. What is the lower energy level? This normal state or ground state which we are talking. So by getting some external energy, electron is excited to the fourth level. But what happens, sir? Due to the mechanics, what happens, sir? Electronic mechanics, the electron which is existing here has to come back to its original state. So whenever it is coming back from this state to this state, it has to release some energy. And that energy, we call it as a photon. We call it as photon. So what is the value of photon? Photon. So the energy released is called photon. What is the value of energy? Photon, sir, photon is something, it is nothing but h into f. What is h? H is Planck's constant. And f is the frequency of the radiating energy. Which we have already discussed in the previous session. Okay. So now what happens is, so we will generally call what we generally call, sir. So now this photon is released. So energy is released, and that, what is the photon, sir? The photon is nothing but P is equal to photon is equal to h into f, the value. So just let me summarize. The electron can move from one state to other state, or it can move completely out, and but it has to, the electron which is completely out cannot come back, but the electron which is moving from lower level energy level to upper energy levels has to definitely come back. So when it is coming back from higher energy level to the lower energy level, it has to release some energy, and that energy is in the form of some light called photon. So how will you calculate the value of photon? Photon is P is equal to h into f, right? P into f is equal to. So this transition from third level to second level or second level to third level will give us UV light, UV excitation. We'll call UV. What is UV, sir? Ultraviolet excitation. Ultraviolet excitation. Okay. If it is moving, let us say, from third to 2, it is moving from 3 to 2 or 4 to 2. 4 to 2 or 3 to 2. This is what, sir? This is IR. What is IR, sir? Sir, this is visible. This is visible radiation. Visible excitation. This is visible excitation. What is visible excitation? Which is visible to a human eye. If the electron is exciting from, or the electron in third level may go to fifth level. It may go to fourth level also. It may go to fourth level also, or it can come back. So this excitement is nothing but IR. This is called infrared radiation. So the electrons which is moving from one state to two state and coming back to its state, or one state to third state, both because this energy will be released, right? So this energy will be released and we can't see that. This is UV radiation. The electron in the second level may go to third level or fourth level, and when it is coming back, it also releases some photon energy, and that energy is visible to the human eye. Because of that, it is called visible excitation. We call visible excitation. Okay, and this is called infrared excitation. What is that? The electron which is there in the third position may go to fifth or fourth, or it may come back. Okay, that is infrared radiation. So either the electron can jump from one state to other state. The electron can jump from one state to other state either by external voltage, external electric field, or it can also, whenever you supply some light, it can also go from one state to other state. That generally what we call it as photon excitation. Either electron can get energy from external field or photon excitation. What is this photon, sir? Light. When you supply some light to an electron. But the beauty is here is if the electron gets some energy, which is not equal to the difference between these two, now what happens, sir? Actually the electron will not excite, right? So what is the difference between minus 13.6 and 3.541? Almost, let's say 10 electron volts is required for the electron to jump from one state to second state. If the photon is giving only, let's say, 8 electron volts, the light which is falling on the atom is giving 8 electron volts, then the electron will not jump to the next level. If and only if it has 8 electron volts, then only it can move from one state to the next state. Clear? And the final important point to be covered here is the electron which is excited may directly jump from, wait, I'll go to the next slide, and here I'll try to draw. For convenience, I have drawn the differences very slowly. So the electron which wants to jump Let's say this is a 1, 2, 3, 4. The electron which is jumping from here to here may not come back directly from here, sir. The electron may jump to third state, or it may jump to second state. It may directly go to the first state. If it is jumping from fourth state to third state, and then third to 2, 2 to 1. So different photons will be generated. Different photons will be generated. The electron which is gain some energy, which goes to the higher energy levels, may not come back to its normal state directly. It may do multiple jumps. Okay, if the electron gets energy from a photon, that light, external light, because of which if the electron is completely detached out of it, then that is called photoionization. Photoionization. Let me repeat this point, very important, sir. Right? If the electron gets some photon, some light in the form of photon, so that it completely goes out of the atom, then and it becomes free. This becomes free. There is no point. So as this is called ionization, right? Just now we have discussed ionization. And this ionization is happening because of what? This photoionization, photon. So because of that, it is called photoionization. This is called photoionization. What is photoionization? When it is moving from this level to the next level, from lower level to higher level, that is when light is falling on it and the photon is absorbed some energy, the electron absorbs energy from a photon, and which is completely goes out of the nucleus or completely goes away from the atom, becomes free. So then that kind of ionization is called photoionization. Hope this point is clear. Now we'll see a problem based on this. What is the problem, sir? Read the problem carefully. Spend few seconds on the problem. Please spend a few seconds on the problem. Please spend a few minutes on the problem. What is saying, sir? A photon of wavelength 1400 angstroms. A photon of wavelength. What is wavelength, sir? Wavelength lambda. A photon of wavelength lambda 1400 angstroms absorbed by a mercury radiated 2 photons. Out of which one is having a wavelength of another. Let's say this is a lambda 1. This is a lambda. Let's say this is lambda. This is lambda 1. Calculate the wavelength of the second photon. So what is trying to say is a photon having a wavelength of 1400 angstroms absorbed by a mercury. Let's consider you have a mercury here. So mercury will consider, right? So the mercury here absorbs some energy absorbs some energy. Absorbs some energy. After some point of time, what happens? What is this wavelength, sir? The wavelength of this is going to be 1400 angstroms. Now, when after absorption, as I told you, again it has to come back to its lower level. Yes or no? Here we are discussing, right? So this photon is going to be what? 1400 angstroms, right? And it is going to, let's say, some place here. So after that, what he has to, he has to come back. So the, what is saying, sir? So it radiates 2 photons. So it radiates 2 photons. So one is having lambda 1, one is having a lambda 1, other one is having lambda 2, other one is having lambda 2. So assume that. So very simple, sir. How to calculate? Very simple formula. So the energy absorbed, solution is energy absorbed must be equal to energy radiated by photon 1 plus energy radiated, simple, energy radiated by photon 2, energy radiated by photon 2. So what it simply says is, assume this is delta E is equal to delta E1. Sir, why we are considering this delta? Because we know the formula delta 2. So why we are considering, we know that lambda wavelength is going to be 12,400 by E2 minus E1. I can also call this as 12,400. This is angstroms, sir. Angstroms. If it is micrometers, what is, sir? If micrometers, 1.24 micrometers. If it is micrometers, 1.24 micrometers. So 12,400 by, can I say delta E? So what is delta E? So delta E is equal to 12,400 by lambda. So here same thing you have to substitute, sir. Simply substitute 12,400 by lambda is equal to, this is also 12,400 by lambda 1 plus 12,400 by lambda 2. So please understand. So don't neglect, sir. Don't neglect. You will not get this kind of material anywhere. Huh? Nobody will teach you, sir. Nobody will teach you. Huh? Okay, try to solve the problem. So now what happens, sir? This is simply 1 by lambda is equal to 1 by lambda 1 plus 1 by lambda 2. What do you want, sir? You want the value of, what you want the value of lambda 2. So 1 by lambda 2 is equal to 1 by lambda minus 1 by lambda 1. So substitute the value of lambda and lambda 1. So what is the lambda, sir? What is the lambda value? I think the lambda is going to be 1400 minus lambda 1 is going to be 1850. So all of them are in lambda Armstrongs only. So 1 by lambda 2. Can somebody calculate what is going to be lambda 2? Calculate what is going to be lambda 2. What is lambda 2? What is lambda 2? Huh? What is lambda 2? You don't have notebooks, huh? Sir, for every class almost we will discuss at least one problem, sir. So better to have always pen and paper. Pen and paper. Pen and paper, sir. Always you should have a pen and paper. So lambda 2 is going to be what? So after calculation, lambda 2, you will get the value as 5780 angstroms. 5756 kind of thing you'll get, but still 5780 angstroms. Approximate, sir. This is approximate. This is the answer. This is the answer. 5755. Correct. Sandhya, correct. Yeah, you can get 57. Yeah. You may get very good. You will get 5756, which I told. So if you take some different values of calculator, so you may get this. This is also correct answer. 5756 is the correct answer. No problem. 5756 is a correct answer. Okay. Now let's move to the next. Yeah. Here comes another important concept called electronic structure of elements. So why this electronic structure is important in an element, right? So it is simply like, if you want to identify some person, there are hundreds of lakhs and crores of people available, right? If somebody wants to send some identify Shravan Kumar, how will you locate, sir? You will locate in which state I am living. Let's say I am living in Telangana state. In which city you are living? I am living in Hyderabad. In which place you are living? Some X place you are living. In which door number you are living? Some door number you will say, right? To locate one person, you need all these parameters, right? Similarly, to describe an electron, you need 4 quantum numbers. So what are they? They are described as N, L, ML and MS. So what these things will define is, this N stands for the shell. In which shell electron is living, or in which shell electron is existing. And then L is nothing but the subshell. It's a subshell, right? ML is energy level. Don't worry, sir, if you don't understand, I slowly explain. I'll clearly explain you. Krishnaveni, good, Krishnaveni. Correct answer. And MS represents the spin of the quantum number. Spin of the electron. As I told you, to describe one electron, to describe one person, you need to know some parameters. In which state he is living, in which city, in which area, in which room, and which apartment, like this. You'll have some different, right? And in which direction, in which area. So all these things, how it required. For electron also, these 4 quantum numbers are important. So the quantum number N is represent the shell of, in which shell it is living. It is existing. Where can I get that? And the subshell in which is existing. The energy level and spin. These are the 4 important parameters. To be known to identify or locate an electron. Clear? So 4 quantum numbers. What are they? N, L, Ml and Ms. So what is Pauli's exclusion principle says? That no two electrons in electron system can have the same set of 4 quantum numbers. Obviously, no human being will have same kind of thumb impression. Yes or no? So many times what will happen, sir? Now we are again moving back to the old system of thumb. A human being is identified or separated if two people are same. Let's say in your classroom, 2 students are same, twins, they are twins, right? So how to differentiate? Generally we don't differentiate, but if you look at their thumb impressions, definitely they will be different. Definitely they will be different. Similarly, no two electrons in the world or in any electron system will have same value of the 4 quantum numbers. What does it mean, sir? Let's say n value is 1 and L value is 1. Example I am telling. And ML value is 1 and MS is going to be, let's say, 1 by 2. But this is first electron. Second electron, let's say N is equal to 1, L is equal to 1, ML is also equal to 1, but MS should be at least equal to minus 1 by 2. The spin of electron minus 1 by 2. The spin of the electron minus 1 by 2. So no two electrons. If it is also having plus 1 by 2, then there is no difference, right? It represents same electron. When all the 4 quantum numbers of an electron are same, then that represents only 1 electron. So no two electrons in the world will have, in the electron system will have same set of quantum numbers. Same set of quantum numbers. Right? Now, so the electronic shells. So as I told you, the N value represents the shell. N value represents the shell. In which shell it is living. Sir, I'll show you this. Now, I think you will understand this very well. So for different values of N, you have different shells. For N is equal to 1, you have only one shell, S shell. For N is equal to 2, you have S and P shells. N is equal to 1 is this red one. N is equal to 2 means green one. N is equal to 3 means this blue one. N is equal to 4 means this orange one. Clear? So we for N is equal to 1, we call this as K. This we call this as a capital N, capital L, and we call this as a, is it visible what I am writing? Okay. This we represent with capital M, and this we represent with capital N. Capital N. If N is equal to 5, can somebody tell me what is for N is equal to 5? Most of the people know this. But what is N is equal to 5? Tell me what is N is equal to 5. What is that? What is going to be the name? What is going to be the letter which you are assigned? Can somebody tell me? Don't know? Don't know? Okay, I will tell. Don't worry. For N is equal to 5, you have O. For N is equal to 6, you will have P. For N is equal to 7, you have Q. Like this, you will have many things. But you see, the beauty here is for different values of N, what we have discussed is same. Then, as I told you, the subshell for n is equal to how the value of n value is going to be from 1, 2, 3, 4, so on. What is the value of L? L is going to be, start from 0, sir. 0, 1, 2, 3, so on, n minus 1. N minus 1. N minus 1. Then what is ML? What is the quantum number ML? What is the quantum number ML? ML is going to be 0 plus or minus 1 plus or minus 2, so on, plus or minus L. Plus or minus L. But MS is having only two values, that is plus or minus 1 by 2. Plus or minus 1 by 2. Plus or minus 1 by 2 is the value. Okay. Now, as I told you, so for n is equal to 1, we say it is K. For n is equal to 2, we say L. For n is equal to 3, we can say KLM, so on. So for, let's say for n is equal to 1, what is the value of L? L is going to be 0 only. For n is equal to 2, what you will have, sir? L is going to be what? For L is going to be what? You will have 0, comma 1, because this is L is n minus 1, n minus 1, n minus 1, n minus 1. So 0, n is, what is the value of n? N is going to be 2. So 2 minus 1, 1. So for n is equal to 3, n is equal to 3, what will be the value of L? L value is going to be 0, comma 1, comma 2. Right? So for different values of L, what should be the value of M? Okay. Now let us consider. So let's go to previous slide. So then here also one important thing is, we have L is equal to 0, L is equal to 1, L is equal to 2, L is equal to 3, L is equal to 4, like this. For different values of n, you will say. So for L is equal to 0, we represent it with S. For L is equal to 1, you represent it with P. For L is equal to 2, SPD. For L is equal to 3, so this is 4, sir, actually 4. For SPDF, for L is equal to 4, now tell me, sir. SPDF you already know. After F, what you will get, sir? G. If L is equal to 5, tell me, what you will get? H. If L is equal to 6, what will you get? What will you get? I you will get. Like this. Probably only you might be knowing only SPDF. But here you have, for L is equal to 4 G, you will get L is equal to 5H, L is equal to 6, you will get I. Right? Now let us see for n is equal to 1, how many electrons can come? For n is equal to 1. So for n is equal to 1, your L is equal to 0. Right? Similarly, for if L is equal to 0, your ML is going to be also 0. Yes or no? Because what is L? What is ML? ML is 0. And here you have MS, one MS is going to be 1 by 2. Another MS is going to be minus 1 by 2. So how many electrons will get? 2 electrons will get. For n is equal to 2, for n is equal to 1, we'll get 2 electrons. Now let's consider n is equal to, for n is equal to 2. For n is equal to 2 means you have L is equal to 0 and then L is also equal to 1. Yes or no? Because L is going to be what? 0, n minus 1. For every value of L, for every value of L, you will have ML. ML is going to be 0. Right? And here you will have ML is going to be, again ML is going to be having two values. M is equal to plus 1, ML is going to be minus 1. M is equal to 1, ML is equal to minus 1. For every of this, again you have some MS. MS is going to be plus or minus 1 by 2. Again for this value, MS is going to be plus or minus 1 by 2. Again this is going to be MS is equal to plus or minus 1 by 2. Plus or minus 1 by 2. So like this, how many electrons you get? Total 8 electrons you can locate. Total you can locate 8 electrons. Correct, Mahendra. Correct, Sandhya. So the earlier you commented I. Correct. For n is equal to 7, you have I. Right? So 8 electrons will get. 8 electrons will get. So if you look at here, what happens? So these are SPDF. So now for you look at here, for n is equal to 1. For n is equal to 1, how many L's you have? How many energy levels you have? Only 1. For n is equal to 2, you have SP 0 and 1. This locates subshells. This is subshell, sir. For n is equal to 2, you have 2 subshells. For n is equal to 3, you have 3 subshells. For n is equal to 3, n is equal to 4, you have 4 subshells. Clear? This is 0 subshell. This is 1 subshell. This is going to be 0, 1, 2 subshell. This is going to be 0, 1, 2, 3 subshells. These levels are increasing the value of L, showing the value of L. Is it clear? Okay. Now, if the value of S is equal to 2, see the energy level you have to mention, right? That if you mention the energy level, for every S you will have 2 energy levels. Here, okay. So for 2 here you have another energy level, or here you have another energy level, here energy level. So the electrons will be located individually like this. And these 3 electrons which are here, so these electrons which are looking here, what you are looking here, let's say P will have how many electrons? You will have 6 electrons, right? In general, 6 electrons you will have. In general, you will have 6 electrons. So these 6 electrons will not also have same value, sir. Though they are in the subshell. Though they are in the subshell of L is equal to 1. These 2 electrons are in the L is equal to 0 subshell. These 6 electrons are in L is equal to 1 subshell. And each of them will have 3 different energy levels. What are the energy levels you have? 0, plus 1, minus 1 energy levels, ML. Right? Let's say these 2 comes under 0. These 2 comes under plus 1. And these 2 comes under minus 1. Then how to differentiate them? These 2 again, this is going to be plus 1 by 2. This is going to be minus 1 by 2. Again this is plus 1 by 2. And this is again minus 1 by 2. This is going to be plus 1 by 2. And this is going to be minus 1 by 2. What is the difference between shell and subshell? Shell, see, you see, shell contain this combining all these subshells. Combining all these subshells is called a shell. This S for n is equal to 1, you have only one shell. It doesn't have any subshells. But if for n is equal to 2, Mahindra, are you listening? Mahindra. So for n is equal to 2, for n is equal to 2, what's happening, sir? You have subshells again. That is S subshell, P subshell. S subshell, P subshell. For n is equal to 3, you have 3 subshells. That is S, P, D. S, P, D. For n is equal to 4, you have 4 subshells. S, P, D, F. Combining all these 4, I can say this is a shell of 4 and represented with N. Combining all these 3 subshells, I am going to call this as a shell M. Understand? Understand? Okay. So, now what's happening, sir? So, this is how we will locate an electron. This is how we locate an electron. You can see here, so, an electron which is having, let's say this is having 2 electrons. 1 minute, I should draw this with some other color so that you will understand. Huh? So how to locate this electron, sir? Let's say this electron I am trying to locate. This location I am trying to locate. First, I should cross this. I should check this. Is it in n is equal to 1? No. So I want to cross already 1s2. No, it is not. This electron is not that. This electron is not that. So next, I am going to n is equal to 2. Yes. 2s1, 2s2. No. Is it in the second subshell? Is it in the first subshell? No. Electron is in the p subshell. Electron is in the p subshell. Electron is in the p subshell. Okay. So how to identify that? So that is 2p. 2p. So whether it is in m is equal to 1, m is equal to 0, ml is equal to 0, ml is equal to 1, m is equal to 3. So this is which electron? 1, 2, 3, 4. Fifth electron, 2p5, 2p5, 2p5 means what is its m value? Its ml value is going to be -1. And what is its ms? Ms is plus R. This is how. Which subshell is fill first? So obviously the lowest shell will fill first. S, after S, P will fill. After P, D will fill. After D, F will fill. But some cases I will tell you. What is the difference. Some cases you will have a problem. I will tell you the problem. Okay, Mahindra. Okay. So this is how you will have shell, subshell, maximum electrons in a subshell, and what is the electrons in the shell. You can see here, for a shell, for K, what is K, sir? For K means n is equal to 1. So if you write n is equal to here, for K subshell n is equal to 1. For L means it is 2. For M means it is 3. This 4, right? So for one subshell, you have 1s subshell, and the subshell contains 2 electrons. Simple, sir. This is 1s. So this blue represents K shell. So this blue one represents K shell. This complete red represents L shell, sir. Complete represents L shell. Okay, so this how many electrons will fill, sir? 2 electrons. We have already know that this can fill 2 electrons. And this 2s can also fill 2 electrons. This 2s can also fill 2s electrons. How many? P can fill 6 electrons. Yes, 6 electrons. 6 electrons. Okay, so now if you want to see what is m is equal to 3, for m is equal to 3 you have SPD. M is equal to 3 you have SPD. So it means you have an 1s or subshell and p subshell you have anyway. You have p subshell and you have also d subshell. D subshell. You have d subshell. So this green represents, this complete green represents this subshell, sir. M subshell. N subshell. Okay. So the second for L value, what you are getting, sir? This is 2. S I can call. This is 2p. This is 3s. This is 3p. This is 3d. So for D you have 10 electrons. P has 6 electrons. So the how many electrons in a shell? Right? For K is equal to 1. For K is equal to 1, you have only 2 electrons in the shell. But for L, that means N is equal to 2. You have total of 8 electrons. You have total of 8 electrons. You have total of 8 electrons. For M is equal to 3. For M is equal to 3, you have S, P, D. S subshell has 2 electrons. P subshell has 6 electrons. And D has 10 subshells. So 2 plus 6 plus 10, 18. 18. For N is equal to 4. For N is equal to 4, you have 4S, 4P, 4D, 4F. So 2 plus 6 plus 10 plus 14, you have 32 electrons. Can somebody tell me what will be the total number of electrons if N is equal to 5? Think. Just think, sir. Just think. How many electrons you can fill? How many electrons you can fill? For N is equal to 5. So this is any. So if the shell name is O, it can fill 50 electrons. 50 electrons. The shell name is P. That is, this is N value is 5. If the N value is 6. N value is 6. This is P. It can fill almost 72 electrons. 72 electrons. 72 electrons. If N value is 7 and will be Q, you will get Q, its name is Q. And how many electrons will get, sir? Almost you will get 98 electrons. Total 98 electrons. Total 98 electrons will get. Clear? So this is what? An electronic configuration. Electronic configuration. Now we will see some important configurations here. Why we are choosing only these 4? Because we need these 4. These are called fourth group elements. We will let you know why it is called fourth group element. You can see carbon's electronic configuration is 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. And silicon has 40 electrons. It is 1s2, 2s2, 2p6, 3s2, 3p2. Germanium has 32 electrons. 32 electrons. That is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p2. Tin is having 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4p6, 5s2. One thing you have to observe here is One thing here you have to observe is, look at this, sir. Look at this. 2s2, 2p2. Look at this. 3s2, 3p2. Look at this. 4s2, 4p2. And you can see here 5s2, 5p2. 5s2, 5p2. 5s2, 5p2. What is the formula for what? What is the formula for what, Nana? What formula? Acha, to know the number of electrons, right? You are changing, right? You are changing here. For F, after F, what you will get, sir? After F, you will get G, right? G, how many electrons? G, how many electrons? So to get 50, so for n is equal to 5, I'll tell you here. Wait a minute. So for n is equal to 5, you will have what? You will have S, P, D, F, and then G. S is going to be what? 2. P is going to be 6. D is going to be 10. F is going to be what? 14. So G is going to be what? You are going to have 18 electrons. So total how many you will get, sir? Count. Whether you are getting correct answer or not. Whether you are getting 30 or not. So 50 or not. So 50. So for n is equal to 6. This is what you are asking, right? This is what you are asking, right? So S is equal to 2, P is equal to 6, D is equal to 10, F is equal to 14, G is equal to 18, H is 22. 22. So how many it becomes? 72. So for n is equal to 7, S is going to be 2, P is going to be 6, D is going to be 10, F is going to be 14, G is going to be 18, H is going to be 22. Then you will have I how many? 26. So how many will become? 98. Understood? Hope you understood. Sandhya, very good. Good that you asked this question, because many people may not understand this. So they may just think why we are getting only 50, 72, 98. So very good, you asked very clearly. So for n is equal to 5, if n is equal to 5, so how many electrons can accommodate, sir? 50. If n is equal to 6, you will get 72 electrons. If n is equal to 7, how many electrons will you get, sir? 98 electrons will get. You will get 98 electrons. Very good. Thank you for asking this question. We'll move on. Now come back to this. We can see all the Mahindra was saying something. We say valency electrons. Okay, valency electrons. I can call outer orbit electrons. Outermost orbit electrons. Outermost shell. I should say outermost shell. These are all outermost shells. This is outermost shell. This is also outermost shell. This is also outermost shell. This is also outermost shell. In the outermost shell, all this carbon, silicon, germanium and tin has how many electrons, sir? Here you have 2 plus 2, 4 electrons. Here you 2 plus 2, 4 electrons. Here 2 plus 2, 4 electrons. Here 2 plus 2, 4 electrons. So in the outermost shell, you have only 4 electrons. See, if in the outermost shell, 1 minute. In the outermost shell, if you have one electron, it is called monovalent. In the outermost shell, if let us say you have, that is like only let's say you have 2s1 or 3s1 or 5s1, 5s1 called monovalent. Next, if it is having outermost shell 2 electrons, it is called divalent. Divalent. So it is nothing but, let's say you have 2s2, 3s2, 4s2, 4s2 or 5s2. If it is having 3 electrons in the outermost orbit, it is called trivalent. How will write trivalent, sir? 2s2, 2p1, 2p1. This is 3s2, 3p1. So like this. If in the outermost shell, if you have 4 electrons, if you have 4 electrons, it is called what we call, sir? Tell me. Huh? Monovalent, divalent, trivalent. This you should tell, sir. This is already you know, right? Tell me, sir. Tell me. Waiting for you. Waiting for your response. Waiting for your response. Monovalent, divalent, trivalent. No idea. If electron has 4 electrons, can you tell me 5? 5 you know already. We call it as pentavalent. Yes or no? It is called tetravalent. It is 2s2, 2p2, 3s2, 3p2, so on. For pentavalent, correct, Sandhya, tetravalent, correct. So this is what, sir? This is going to be 2s2, 2p3, 3s2, 3p3, like this. So all these comes under 4th group elements. So tetravalent. So we call this as 4th group elements. Because in the outermost shell, they have 4 electrons. In the outermost shell, they have carbon, silicon, germanium and tin. Pentavalent is for, yes, correct. For 5, will get correct. What you are saying is correct. So these are called 4th group elements, right? So only outermost shells are not filled, and they are having 4 electrons in their outermost shell. In the outermost shell. Okay, clear? Pentavalent 5, correct. Krishnaveni, correct. Krishnaveni, correct. Okay. Now we'll move on. So till that we have identified how to know the electron. That is what electronic configuration. Hope you understand how the electron has come. Now, this is a very important concept now we have to discuss is the energy band theory of crystals. The energy band theory of crystals, which is the most important topic. So, most metals and semiconductors are crystalline in structure. So, what do you mean by crystalline in structure, sir? Crystalline structure, what do you mean by crystalline structures? So, what do you mean by crystalline structures? What do you mean by crystalline structures? So, crystalline structures looks like this. So one electron is here, one electron is here, one electron is here, so one electron is here, so one electron is here. See, for all the corners of this cube, you have electrons. For all the corners of the cube, you have electrons. Atoms are added, are arranged in a proper way. Okay. So the crystalline looks like this. So this electron is shared by these three. It will share another electron also. If it is 4. So the crystalline structure. The crystal consists of a space array of atoms built up by regular repetition in 3D. So this is again repeated. This complete is repeated. Okay. That we will discuss. When an atom forms crystals, it is found that the energy levels of the inner shell's electrons are not affected appreciably by the presence of the neighboring atoms. The levels of the outer shell, this is shell, outer shell electrons are changed considerably since these electrons are shared by the more number of atoms in it. Okay. Now, here I try to draw. Let's consider two silicon atoms. Not coming. Okay, leave it. Just wait a second, just give me some time. I'm trying to draw this. Okay, now see, let's assume that this is one silicon atom, this is one silicon atom, this is another silicon atom. Right? When these two silicon atoms are brought together, when we are trying to bring them close, we are trying to bring them close. So what happens, sir? These inner energy levels or inner orbits are fixed. They have lot of energy. Inners will have lot of energy. So the electrons which are revolving in these inner circles, inner orbits, will not move anything, sir. Their energy levels will be same. But these outer electrons, the electrons in the outer orbit, the energies of the outer orbits come closer. Clear? Right? So when they come closer, now what is saying? See, the levels of the outer shell electrons are changed considerably since these electrons are shared by more than one atom in the crystal. So when you brought these two together, now as I told you here, this electron is shared by 1, 2, 3 electrons, 3 other electrons, or 3 atoms. The outermost electron of this atom is shared by many. 1, 2, 3, whatever. So now what happens, sir? The core, the energy levels of the electrons in the core orbit will not be altered. They are fixed. They are fixed. But you can see here the energy levels of these outer orbits, outer electrons or electrons in outer orbits will be altered. Will be altered. So see, now I am talking about only 2 electrons. In an atom, in a molecule, what you will have, sir? You will have many number of atoms. So all atoms, let's consider some n number of electrons are coming. N number of atoms are existing. So how many outer electrons you have? How many outer electrons are? You have n electrons. So all those outer electrons levels will come together. Though these internal energy levels or the lower energy levels will not be altered. Sir, understand very clearly. This is very important. This is very important. The lower, when electrons are brought together, the lower energy levels will not be altered, but the outer energy levels, higher energy levels will be altered, changed. Higher energy levels will be changed. Higher energy levels will be changed. So now what is saying? The new energy levels of the outer electrons found that coupling between outer shells, you can see coupling between outer shell electrons of the atom results something called band of closely placed energy states. So this is called energy band. This is new thing called energy band. Right? All the outer electrons, when they combine, one electron of one atom, other electron of other atom, other electron of other atom, when they come together, the inner electrons will not be altered. The energies of inner electrons will not be altered, but the outer shell electrons energy will be come together and they will form some band. They will form some band, some bond. The closely spaced energy states called band, and they are called energy bands. Energy bands. This is very important, sir. This is what energy band is. This is what. So how energy band will form, sir? The energy band will be formed by coupling between the outer shell of electrons, outer shells of the electrons. Clear? So did you understand what I mean? 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 Huh? Did you understand what I mean? Okay. Did you understand what I mean? So we will stop here because I have to discuss many things now. Right? We will stop here. We will stop here. So we will restrict our discussion to energy band only. So if you bring if you bring many electrons like this, 1 electron, 2 electrons, 3 electrons, 4 electrons, 5 electrons. So all these energy levels, outer electron energy levels will form a band. You can see here, this is one energy level, this is another energy level, this is another energy level, this is another energy level. So this range of energy levels, this range of energy levels no, different atoms in a crystalline material. No, how can you say it is same atom? No, same atom. No, these are different atoms. Different atoms, Mahendra. Different atoms, Mahendra. Sir, why don't they repel? Krishnavedi, they don't repel. Because they will come together, right? Because you have put them in the same crystal. If it repels, what happens? They have to go away. Right? Here, what is happening is that I am talking about the energy levels. The energy levels. The energy levels. Is it clear? Yes, whatever you said is correct. Two electrons when to come together, they will same charges will repel. Let's say you are saying repel also. For repel also, what happens is the energy level will increase, right? They form a new energy level. They form a new energy level. All the electrons in the atoms, outer shell electrons of each atom will form a new energy level. New energy level. And this range of energy levels is called band. What is this band means? Energy band. So, this may become one energy band. This may become one energy band. This may become one energy band. Let's say one energy band. Some electrons may form another energy band. It's called energy band 2. You have another energy. So, different electrons will form different energy bands. So, we will restrict our discussion for this point. So, we will continue our discussion tomorrow and the next class. So, we don't have class tomorrow. Tomorrow we will have class. Tomorrow we will have class in. We have class tomorrow. That is 5/12/2020. We have a special class which is a free class, which is a free class on Unacademy app. What is topic, sir? Topic is going to be simple diode circuits. Simple diode circuits, clippers. Saturday, Sunday, generally I don't. Saturday, Sunday I don't teach, sir, on YouTube. I teach on Unacademy app. Unacademy app. This simple diode circuits comes under analog electronics. And the time is going to be 10 a.m. to 11 a.m. Tomorrow's class, we have special class which is also free class on Unacademy app. I request you to download the Unacademy app and search with my name or search with topic simple diode circuits, clippers. This is subject is going to be actually analog electronics. Is there any EMT subject like classes? So now I am not teaching any EMT, but in future, Krishnavedi, definitely I will teach EMT also. You need not worry. But let me finish first EDC, then come to other subject. Come to other subject. My first focus is on EDC. After finishing EDC, I will come back to other subject. So in parallel, I am trying to cover analog electronics. In parallel, the different topics of analog electronics will be covered in Unacademy app. So tomorrow time is going to be 10 a.m. to 11 a.m. So I will see if possible I will shift this class from next week onwards. From next week onwards, I will try to shift this class to night 9 p.m. to 10 p.m. because few students 9 p.m. to 10 p.m. 9 p.m. to 10 p.m. Okay. So next week, from next week onwards, from next week, you will have it is Unacademy app. So EDC will be taught from Monday to Friday on YouTube. From 5:30 p.m. to 7:30 p.m. EDC and special classes will be from Monday to Friday. You will have from 9 p.m. to 10 p.m. 10 p.m. We will give. Yeah, you can download these notes, Mahendra. You can download these notes from that Telegram channel. Pradham, complete Hindi is not possible. Pradham, complete Hindi is not possible. I am not from the state of Hindi religion, but I try to teach in Hindi. So tomorrow's special class. You try to attend tomorrow's class, and weekend, that is Saturday, 2 classes I will take special classes, 2 special classes. For that, we should search in or follow me. That is, you can search SHRAVAN KUMAR Kumar, Shravan Kumar, in the Unacademy app. In Unacademy app. Okay. In Unacademy app, you can see. Sir, we have online classes 9 a.m. to 4 p.m. Sir. Please continue after 4 p.m. Only tomorrow. Krishnavedi, only tomorrow we will have 10 to 11. This is only for tomorrow. 10 to 11. This is only for tomorrow. What you can do is, you may not come to online, but you can listen to the class afterwards. Please watch, ask other people to watch, and please like and comment. Don't miss it. Okay. So we'll continue all these things in the next class. So we have different channels also. Creatrix Gate, WEC in Unacademy Gate for mechanical and everything. Unacademy Civil we have. Unacademy Gate Telugu we have. And then we have Unacademy SSC. Mahendra, I'll show you here. The link of Telegram. Unacademy. This is very good, sir. Gate questions, complete gate questions on Unacademy. And you have electrical junction for electrical people. Unacademy Engineering Foundation, and Engineering Pathshala. These are the different YouTube channels which Unacademy is running. This is a different YouTube channel which is Unacademy running. This is what Telegram. This is a Telegram channel. You can note down. Mahendra, you can note down or take a screenshot of it. Otherwise, Creatrix Gate double E. Telegram. In the Telegram, you can simply type Creatrix Gate double E. Okay. And this is what you use the referral code to subscribe, to get Unacademy subscription. Use this referral code and get 10% discount on it. 10% discount on it. Please subscribe yourself for more practice and everything. In the next class, we will discuss in detail. About we'll continue our discussion. Thank you all. Good night. Bye. Good night.